So today is Monday, April 15th. This says calculator inactive. When you take your state EOC the first week of June, you'll notice that the first 19 questions, typically it's between 18 and 20, are calculator inactive. No calculator. You're going to have questions just like this, meaning that you can't use a calculator for this. So we have to know how to solve it, right? We have to know how to solve it. We have to know how to solve it with just using basic math skills, okay? So how do we solve a quadratic? What are the steps? Well, first, we replace the y with a 0, right? Do you guys remember that? And then second, you have to factor. So this really is the equation 0 equals negative 2x squared plus 4x minus 6. What is the number one rule of factoring, Jordan? Number one rule of factoring. What do you look for first every time? Help them out, Emily. What do you look for first every time? A GCF. Yeah. Does anybody see a GCF in here? What is it? It's negative 2, right? Because we don't want our leading coefficient to be negative. And I will tell you guys that this has a typo. This should say 4x plus 6. Can everybody turn that into a plus 6? I was supposed to fix those, but I got busy. Got it? Everyone wrote that as 4x plus 6? Okay. So let's see. If we factor out that negative 2, we have 0 equals negative 2 times, let's see, negative 2x squared divided by negative 2 is just a positive x squared. 4x divided by negative 2 is negative 2x. And 6 divided by positive 6 divided by positive 2 is a positive 3. Why? Oh, that should be a negative 2. Sorry. So positive 6 divided by negative 2 is a negative 3. So you should have negative 2 parenthesis x squared minus 2x minus 3. So we have to factor this. This is saying find two numbers that when you multiply them, you get negative 3, but when you add them, you get negative 2. Well, there's only one pair of factors that multiply to 3. What are they? There's only one set of numbers that you can use to get to 3. 3 times what is 3? 3 times 1, and that's it. There's no other factor. So one of these has to be negative and one of them has to be positive. Which one is it? Negative 3, positive 1. So this factors to x minus 3 times x plus 1. Remember that these are my factors. These are my factors. What can you tell me about my factors compared to my x-intercepts, which are also called roots or solutions or zeros? What do they have in common, or how do they compare to a factor? How do the factors right here compare to the roots? They're the opposite signs. Thank you so much for saying that. So what is the opposite of negative 3? So x equals positive 3. What is the opposite of positive 1? So x equals negative 1. What are these two numbers telling me about my graph? These two numbers are telling me what? Yeah, this is where I cross the x-axis. I cross at negative 1 and I cross at positive 3. Perfect. I'm going to just put those points there. Okay. What is the y-intercept? Where do I cross the y-axis and how do you know? So say it again, Bryce. So if I want my y-intercept, I need you to write it as an ordered pair. So what's that going to be? 0, 6. And how do you know that? Because I told you guys it's 0c. So if your quadratic function is written in standard form, the last term is c. So let's go to 6 on the x-axis and let's plot that, or on the y-axis, sorry, and plot that point. Okay. Now it wants us to find our vertex, but we haven't even found the axis of symmetry. So we're going to have to go down and do the axis of symmetry and then go back and do the vertex. Okay. So someone tell me, how do I find the axis of symmetry? The opposite of B divided by what? 2A. Good job. So let's look at B right now. B is a 4. B is a 4. Do you guys see that? This is the B term right here. So B is 4. So the opposite of that is, so negative 4 divided by 2 times. Well, let's go look and see what A is. So A is my leading coefficient. A is negative 2. So let's put that down in here and see what we get. So I really end up with negative 4 over 2 times negative 2 is, so what is negative 4 divided by negative 4? It's 1. X equals 1. That is my axis of symmetry. How do I draw that on my graph? I forgot. What's it look like? It's a dashed line. It's what else, Savannah? Oh, dashed line. I thought I heard someone say vertical. It's a vertical dashed line that goes through x equals 1. So we're going to draw this vertical dashed line. Okay. Can you guys see it? I did it in red. So now I know that my axis of symmetry is x equals 1. How do I use that to find my vertex? Huh? It is where the parabola crosses the axis of symmetry. How do I find that? Sure you do. We did it last week over and over and over again. What do you do with your axis of symmetry? You take the value of x and you plug it into what? Yeah, you plug it into the equation. So y equals 2 times 1 squared, right? Plus 4 times 1, because isn't it plus 4x? Yes? Plus 6. And I think that this 2 out front is a negative. So what is 1 squared? 1. What's negative 2 times 1? Okay, so I have negative 2. And what's 4 times 1? Plus 4 plus 6. Negative 2 plus 4 plus 6 is? What's negative 2 plus 4? Or 4 minus 2? 2 plus 6 is? Okay. So that's what y equals. This is what y equals when x is 1. So the vertex is the ordered pair 1, 8. So I'm going to go 1, 8, and I'm going to plot that point. How many points do you need for parabola? 5. How am I going to get another point? How am I going to get another point? It does. It has to be the same distance away from the axis of symmetry. Awesome job. So how far is my y-intercept from the axis? 1 grid. So can't I go 1 grid in the opposite direction? And now I have that symmetrical, beautiful parabola, and I can connect all of my points. Okay. All right. Tell me about the domain, Delaney. What do you know about the domain? What are the x values that you can use to plug into this function? It is all real numbers. Yes, ma'am. Michael, tell me about the range. Tell me about the range. It has to do with your vertex. So look at your vertex. Is your vertex the highest point or the lowest point on your graph? It's the highest. It's a maximum. So that means that all of the other y values are going to be bigger than that or less than that? Less than. So y is less than or equal to, what is the y coordinate of your vertex? 8. So y is less than or equal to 8. Okay. That is your warm up. We have to just talk about those last two statements down there, increasing or decreasing. So remember that your vertex is called your turning point. You're awesome. Thank you, ma'am. Your vertex is called your turning point. So before the vertex and after the vertex, that's how you need to think about your graph. You need to think about it and kind of divide it into two halves. Let that axis of symmetry split it, right? So what happens before the vertex and what happens after? So when I look at the yellow side of my graph, is y getting bigger or is it getting smaller? It's increasing. When I look at the blue side of my graph and I go from one point to the next point to the next point, is y getting bigger or is it getting smaller? It's decreasing. It's getting smaller. So what interval does it increase? Well, all of the numbers that come before the x-coordinate of the vertex. So that's all the numbers that are before or less than 1. So that's the x-coordinate of the vertex. It's decreasing after all of the numbers after the vertex. So it's greater than 1. Decreases, it's greater than 1.